Thank you for stopping by. My name is Irfan. I'm a maker. You're watching episode 8 in a multi-series where I capture my beginner's journey designing and constructing an Arabic oud instrument. In episode number 6, I had shown how to construct the oud bowl profile templates, so how to design them and how to construct them. So before I move on to the next phase of the project, which will be primarily focused on the construction aspects of the oud bowl, I just wanted to wrap that initial phase, because in that episode 6, I had not gone into details on how I marked the secondary arc or the secondary curve. And again, I use the words arc and curve interchangeably, and I'll explain in more details. So let's deep dive into that. I'm going to give you some concepts and then demonstrate and give you some options on how you can mark that secondary curve. So let's look at some key concepts on the geometry of the primary curve for the oud bowl, the profile template. And the reason it's important because it changes the method that you're going to use to offset to get that secondary curve. Okay. Now this is a compound curve. It's not a circular arc. Circular arc meaning that circle with a fixed center pivot point. Okay. This is a compound curve. Okay. And our objective is that we want to create a constant distance offset curve, which is the secondary curve, and that offset is equal to the rib thickness. Okay. Now, in order to understand how we're going to do that, we got to understand the concept of a tangent. Okay. So the tangent of a curve at a point, and again, it's local, it's at a point, right? It's a straight line that touches the curve at one and only one point. Okay. So here I've drawn a tangent just for illustration, and it's touching this primary at just this one point where my pointer is. Okay. All right, and the reason it's important is because one of the key rules to get the secondary curve is that you must mark this point on the secondary curve equal corresponding to this local primary. It must be marked perpendicular to the tangent at that local point. Okay. So if I draw a tangent line, right, and again it's at a local point, and a perpendicular from that local point or at that local point, perpendicular to the tangent, and I measure 2.5 millimeter, the rib thickness on this perpendicular line, right, that would give me that offset. And that is the key concept. So again, let me reiterate, okay? So the rule that we must follow is that the secondary curve, the points, right, the points on the secondary curve, they must be marked perpendicular to this tangent, right, at that corresponding point on the primary. So if I move this tangent along this curve, along the primary curve, and then at each of the points, each of the local points, I draw perpendicular. And on that perpendicular, I just measure 2.5 millimeter and mark a dimple or a point, and then join those points. That would give me my secondary curve, right? So that's the simplistic view of how you're going to go about getting that secondary curve. Okay. Now the tangent is physically providing the direction of the curve, and the offset curve, right? The secondary curve must follow the same flow and direction as the primary, right? And you get that by what I just described. That if you move this tangent along the primary, and at those local points you drop a perpendicular, measure the 2.5 millimeter, and mark a point, and then join those points on the secondary, you will get the secondary curve. Okay. Now I'm going to show some methods on how you can make it a little easier, but in the workflow, either method that I'm going to show, right, to get this approximation of the secondary in the workflow, you have to verify it, right? and I'm going to talk about what that workflow is, right? But the challenge when you mark it using one of the tools that I'm going to show is that the profile curve, right, is gentler to the middle, right? It transitions towards the neck, and then and towards the tail, it's even. It goes into a much tighter um, transition towards the tail, right? So that makes it difficult to accurately mark the secondary curve. Okay. So on the next slide, let's look at some of the options we can use to mark that secondary curve. Okay. And I'm going to demonstrate a couple of these, right? So you get a feel on how I did it. Okay, so on the left-hand side, I'm just showing a standard marking gauge that you typically use to mark parallel straight lines. A standard divider, so it has two legs with extremely fine points, and then an offset marking gauge that I had designed and built. So this concept of this offset marking gauge is very similar to the standard marking gauge, except that the fence is thin. Here you see the fence is fairly thick, and that creates an issue when you are trying to run this fence on the primary curve. So the concept here on this offset marking gauge, you got a thin fence which is at 90 degrees to the scribe, okay? And you will run the fence on the primary, and the scribe is going to drag or dimple the points on the secondary. The distance between this scribe point and the fence is exactly 2.5 millimeter, okay, which is my rib thickness. Okay, and I'm gonna, like I said, I'm gonna demonstrate and show some details here in a minute or so, right? So you get a feel of, what and how to use this, okay? So on the standard marking gauge, the issue is that the thick fence, if you're running it along this curve, okay, along a compound curve, instead of a single local point, it references multiple points simultaneously and initially instead of that single point, which was the concept of the tangent that I presented in my previous slide. Okay, so the custom offset gauge, it does a little better because of the thin fence, but as you go on that tight curvature right on the tail, although the error is reduced, but the underlying geometric limitation is not eliminated. The divider or a compass, you can use a compass, right? It behaves closer to that point-to-point contact normal transfer that I talked about in my prior slide, and this divider is geometrically the most superior out of the three options. Okay, so either option you use, right, it's going to give you a starting secondary offset. It's not going to be the final. So my verification workflow, right? I generate the offset. You can either drag the marking gauge or the divider, right? Or you can dimple along these points and then use something like a French curve to connect those points, okay? But in the workflow, it is extremely critical, and I cannot stress this enough, right? That you got to verify. So you verify from the center line, and I'm going to show how I do it right in a minute here. And you also verify from the curve using a divider set at the thickness of the rib. Okay, and you can check the smoothness. It has to be, at the end, right? We're not building a rocket ship, right? These templates must be precise, but more importantly, these should be smooth and balanced. And visually, you can get a pretty good feel. Okay. Now it's optional, but you can also use you can fair the curve with a batten. And before CAD and all the software that was developed, that's how builders used to do it, right? You can get a plastic drafting spline. You can look it up online. You can use that to fair the curve. But I think for the purpose what we're trying to accomplish here, that's an overkill. Okay. So again, if you had a CAD package, and I'd mentioned it in one of my earlier presentations or earlier episodes, if you use something like a Fusion 360 to get that offset, is a click of a button. But I think it's important that, at least for me, I want to do it by hand, at least my first pass, so I get a feel of the geometry and I deal with these constraints and get a good feel of what works and what doesn't work.
So if you look at the offset marking gauge, I did a very simple construction. I just used a angle bracket I had laying around. This is a perfect 90 degrees. I put a piece of plywood, pretty flat, and in this corner I put a scribe, and I made sure that this distance from this surface of the plate, the fence, to the tip of that scribe is exactly equal to the thickness of the rib. In my case, 2.5 millimeters. Okay. The important thing here is that these two surfaces have to be perfectly 90 degrees, and this scribe has to be perfectly straight. It requires a little bit of finesse to make it happen. Okay, but it's not that hard. For the scribe, all I'm using is a piece of nail. That is it. Okay, just a piece of nail. Right, and to give this exact 2.5 millimeter distance, what helps is if you have a piece of I used a 2.5 millimeter plywood, right? So I kept it between the tip of the scribe and the surface, so that gave me an exact 2.5 millimeter gap. Okay, so here's a 2.5 millimeter piece of plywood. So you just knock it in right on that tip. Don't push it all the way down, otherwise that scribe is going to get skewed, because since I'm using a nail, the diameter of that tip is different, just slightly, but it's different than the diameter that is sitting on that base of this piece of plywood on this end. Okay, so you just let it touch the tip, but that would give you a fairly good approximation of the 2.5 millimeter gap. Okay, so the scribe I'm using, the nail, I shaped the tip using a machine file. So I kind of flattened it a bit, so that helps prevent wood fibers tearing as I'm dragging it on the surface of the template. And you got to use a very light touch when you drag it. Dimple method sometimes is preferred, but even if you drag it, that gives you that secondary curve. Just use a light touch, and you can then use a pencil to complete it. So this is another view of that fence. Drill those holes. It doesn't have to be metal, it can be wood. Has to be 90 degrees. The fence that runs on that outer curve has to be thin, and then the scribe has to be parallel to this fence. Okay, so as I showed at the beginning of this video, this thin fence, you run it on the outer curve. Okay, and you let this surface rest on the top face of the template, right? You can see, I don't know if you can see, but the scribe is gonna touch that 2.5 millimeter mark. Okay, It's always going to be easier if you start from the neck side and then you move towards the tail side. The curvature on the tail side, it gets sharper, right? And as I explained under the key concepts, on this flatter surface, you will have this fence pretty much touch at a point just opposite the scribe, but as you go on the tighter section of the curve, it's gonna deviate, right? Okay, and in that initial video, if you look carefully, when I'm doing towards the tail side, it kind of starts to shift a bit. Okay, so as an alternate to the custom offset tool, you use a divider, right? If you notice, each leg of the divider, it is closer to a point. Okay, the way to do this is you start from the neck. The curve is more gentler and it gets tighter towards the tail. So it's going to be easier to give you a feel if you start from the neck. So you keep one leg of the divider, you hang it on the outer curve, not on the surface of the template, but hang it on the outer curve. You tilt the divider towards the direction of movement. Okay, so I'm right-handed, I'm holding the divider in my right hand. I lay the divider one leg against the outer curve, lay the second leg on the surface of the template, tilt the divider toward the direction of movement, and let the divider leg follow the curve. And you lay out your secondary curve right here. So this leg right here, either you can dimple it or you can drag it, either approach. Okay, so either you use the divider or the offset gauge. Divider is obviously preferred. You can use a compass, right? But after you are done marking the secondary curve, it's going to give you an approximation. Okay, you know, in the workflow you must verify, and there are two steps in the verification. Okay, so what I do is I go back, I use a graph paper on the templates, it makes it easier, but I go back using a straight edge. I then measure, so I already have the distance, I've already captured, I know what this depth is on the inner curve, because from the outer you just subtract off the thickness of the rib, and that's going to give you the dimension of the depth of that inner. Okay, so I already know this is a known, right? Just use a straight edge and make sure that you are accurate. Okay, so you do this using the straight edge. Okay, and then in addition, what also helps is that you go back from the other side. Okay, so you open your divider, you set your divider to the thickness of the rib, and then on each one of these points, right, you keep the divider and you re-verify and make sure that it's an equal, in my case, the 2.5 millimeter all the way through that secondary curve. Okay. So in this episode, I've tried to do my best to provide the concept, the geometry of the outer and the inner profile curves and also the different methods and options that I use to mark and verify in my workflow. At the end of episode 8, you should have a pretty good feel on the design of the OOD bowl, the different options that I showed in my previous videos, and also how to construct the outer and the inner OOD bowl profile templates, which are critical starting points for the downstream parts. Starting with my next episode, episode number 9, I'm going to focus on the construction of the OOD bowl, and I'll start with the design and build of the neck and the tail block. I hope you found some value in these episodes and will continue finding value in my future episodes. I would love to hear back from you. Please leave a comment, and I look forward to see you in my next episode.